Are you still measuring color like they did in 1885? Do you need color and turbidity at any path length? In this presentation, we'll explain how the HunterLab Vista is the perfect solution. My name is Charles Lategano, and I've been a color scientist at HunterLab for the last 16 years. Today, we will describe a way to improve the current AOCS 13J method. The current AOCS automated method of assessing the color of refined fats and oils requires that the oils are visibly free of turbidity, that's particulates and moisture, because the clarity of the oil affects the color result. They require the user to do a visual assessment of turbidity prior to doing an automatic filter selection determination of color. Turbidimeters are instruments that can objectively determine clarity of oils, and spectrophotometers can provide objective results using cell path lengths of 10 to 20 millimeters that correlate with current 5¼ inch cells. Advances in instrument design such as the Vista enable a user to prepare a single sample and record both turbidity and color from a single measurement. These instruments remove the subjectivity inherent in human eyesight from the visual inspection process, resulting in more complete and more consistent reporting year after year. Clarity is used to describe the clearness of a sample relative to water. Nephelometric turbidity units, NTU, is a visual standard used to grade the appearance of liquids, just like Lovibond color filters are a visual standard. The pharmaceutical industry and others employ 4 ranges of NTU levels when describing clarity. Okay. Level 1 or range 1, which is 0 NTU to less than 3 NTU, would be considered water clear. Okay. Range 2, 3 NTU to less than 6 NTU, is considered visually clear to the trained observer. At range 3, which is greater than 6 NTU to less than 18 NTU, this is where the typical observer notices clarity disappearing. And at range 4, we're at the limit of what would be considered a clear sample. You can look at the poster to see a neutral representation of the turbidity levels or ranges that I just described. These levels are constant for any hue: red, yellow, blue, of course neutral. If we initially report the turbidity, it will allow the recipient of a certificate of analysis to know the true clarity associated with the sample color. The primary purpose of method 13J is to measure the color of a fat or an oil automatically. This presentation will show that turbidity affects color. And to prove this, what we want to do now is measure the color of the same sample that we just determined the turbidity for. We can do this because in 1972, the U.S. National Bureau of Standards, now known as NIST, repeated spectrophotometric measurements of a set of Lovibond color filters. This supersedes earlier measurements that had been done at NIST at the request of the tintometer company. These measurements allow one to use a spectrophotometer to measure the transmittance of a solution and then find the corresponding filter color. A spectrophotometer is an instrument that breaks light into component wavelength bands. For color measurement, typically 31 bands at equal 10 nanometer intervals across a visible spectrum is considered the minimum resolution recommended by the International Commission on Color, the CIE. This measured data follows Lambert's law, which states that absorption is directly proportional to the thickness of the sample. This allows a user to measure using commonly available cells with 10 millimeter or 20 millimeter path lengths, including disposable cuvettes, and other cell sizes as well, such as 24 millimeter vials, 33 millimeter, or 50 millimeter cells. Okay. This graph is the NIST representation of the Lovibond glass filters, which form the basis of the AOCS RY scale. And the graph shows how these filters plot in human color space. Spectrophotometers are calibrated independent of color filters. Spectrophotometers use the laser lines of mercury, krypton, and argon to set their wavelength scale. So method 13J is based on the automatic determination of color when you use 4 sets of Lovibond colored filters or 2 sets of AOCS filters when you measure a sample in a 5 1/4 inch or a 1 inch cell. The AOCS instructs the user to first measure in a 5 1/4 inch cell, and if the resulting color is too saturated, then the user must prepare another sample in a 1 inch cell, remeasure the 1 inch cell, and report that result. This needs to be done since a filter colorimeter is limited to only being able to match the color of a solution using their 3 or 4 primary colors at a set path length. Spectrophotometer were used to measure the colors. Then, if the user determined that the 5 1/4 inch equivalent result was too saturated, they could then automatically recalculate the value as if it was measured in a 1 inch cell. HunterLab has conducted studies similar to what's outlined in method 13J, where identical samples were measured both in a colorimeter, the PFXI 995, using a 5 1/4 inch cell, and a spectrophotometer, the HunterLab Vista, using a 10 millimeter path length cell. The results of a statistical t-test gave p-values equal to 0.0005 between the results, between the instruments. Statistically, there is no significant difference between the results. This was done for both AOCS-R and AOCS-Y colors. Additionally, similar results were achieved for Lovibond R and Y colors. Next, a study was done where the same sample was measured in the 3 most commonly used cell path lengths, 10 millimeter cuvette, and remember, cuvettes made of optical lens grade acrylic are inexpensive enough to be disposable. No need to clean the oil or fat out of the cell after measurement. It can be discarded or retained, and we do the next measurement with a new cell. We used a 20 millimeter large format glass cell. These cells are 50 millimeters tall by 50 millimeters wide with a 20 millimeter path length. Additionally, we used a 24 millimeter diameter vial. These are glass cylinders, optical glass. They're 50 millimeters tall. They have a threaded throat, and they come with a sealing cap. A filled and capped sample eliminates the chance for spillage. It's very easy to heat these in a water bath, and then you can quickly transfer the vial to the spectrophotometer for measurement. Even including a calibration flash before each measurement, the Vista takes 5 seconds or less to measure a sample. These vials are also suited for aging or stability studies, as a sample never has to be removed from the sealed vial throughout the study period. The results here show there are no appreciable difference between a range of 5 Lovibond colors, or 5 reported colors in the 5 1/4 inch cell path length, and any of the other path lengths that were used. This proves that Lambert's law applies to the measurement of oils and fats. So in conclusion, turbidity can indicate that filtering is complete, providing more consistent results. And reporting turbidity with color from a single sample preparation eliminates any variations between preparation or temperature of the sample, etc. The edible oils on the next page were initially determined to visually be free of turbidity. Instrumental analysis, though, showed the oil was in turbidity range 2. Further filtering moved the oil to the low end of range 1, and notice that the color measurement changed. Okay. The Y value was more intense after the turbidity was removed. Recording both instrumental measurements of turbidity and color would be an improvement to the AOCS 13J method. The precision statement and results for this method are now 26 years old. They do not include modern instruments that employ a spectrophotometer to measure the color. Users would benefit from a global study showing that spectrophotometers can reproduce the same results as visual colorimeters and visual comparators. It's time to revisit the current AOCS method. By doing so, AOCS will facilitate the use of advancements in technology, meet the growing needs of edible oil manufacturers, help streamline their refinement processes, ease product transfer from producers to buyers, save time, save them money, and help them maintain control of their bottom line. AOCS is positioned to help edible oil producers, buyers, and resellers use the most efficient means available to determine the quality, color, turbidity, and full spectral curve of their products. For customers, HunterLab is the right place to get all those answers. I want to thank you for taking the time to listen to this presentation.